On November 21st, 2016, Melbourne experienced the worst thunderstorm asthma event in history. Severely high levels of allergens like pollen and fungal spores caused unprecedented consequences. Thousands were hospitalised for severe asthma attacks. Ambulances were delayed for hours and 10 people died. Melbourne is not new to thunderstorm asthma events, however, as we'd had 6 before this. So how do we not see this coming? How do we miss this? Well, the problem is that our current technology is extremely outdated. This black and white photo is of the first pollen and spore trap invented in the 1950s. These machines work by taking samples from the air that scientists, like myself, analyse to aid in thunderstorm asthma research. And the colour photo below is of the exact same model trap that is still used today at Deakin University and other research facilities across the country. The only difference between the traps in these two photos over the last 70 years is a fresh coat of paint. Not only are they extremely outdated, they're also incredibly slow and take a full day to collect samples that then need to be manually analysed. We didn't even know that a thunderstorm asthma event had happened on November 21st in 2016 until the following day. My solution is to develop a modernised technology to improve our ability to detect these allergens and provide a better warning system for thunderstorm asthma. This diagram is of the sensor I'm building to do just that. This is only one aspect of my research, but it's the part that I'm most proud of. So to start, the sensor is built on top of a tiny electrode that's only 2 centimetres wide. It basically acts as a miniature scale that's designed specifically to weigh and detect allergens like pollen or spores. Now, constructing the sensor is similar to constructing a building. It needs to have a solid foundation. So that foundation in this case are these red carbon chains. I spent the last few months optimizing this step so that the little blue antibodies on top work as efficiently as possible. Their job is to recognize the specific allergens that we're wanting to detect, such as these yellow pollen grains. The antibodies will find and stick to the pollen grains, making the sensor heavier. It will then send a signal to a connected computer telling us there's pollen. Not only can the sensor tell us that there's pollen in the air, it can also tell us how much, so we can differentiate between a low amount and a high amount. So instead of relying on outdated technology that takes 24 hours and requires manual work, this sensor will be able to automatically detect allergens in under 1 hour. This will not only significantly shorten our detection time, this will also provide an actual real-time effective warning system for thunderstorm asthma. In addition, because this sensor is so small, we can eventually develop a portable version that people could wear to detect rising allergy levels around them. I hope you can breathe easy, knowing that I'm reducing the risk of thunderstorm asthma.